Hello everyone, I've set my clock, so hopefully I'll only be 10 minutes. So I'm going to talk to you about a project that has been running since 2018, looking at circularity and sustainability in the data center industry, but in particular, the development of a digital tool that is free to use. So everybody, I guess, is familiar with the stats around the growth of data centers, the fact that growth is ongoing, and although numbers vary a bit, we expect expansion based on 10% annual increase to double by 2030. And there's lots of statistics, etc., numbers, goodness knows what else, about energy use, but nothing really comprehensive about materials. But we do know that there's a vast volume and mass of materials sort of embedded in the data center industry. For instance, in a 1,000 square meter data center, you have about 10,000 servers, which accounts for 250 tons of materials. So we've got a big problem here. The speed of development in the sector means that everything was designed in a linear fashion, take, make, use, and dispose without any consideration of what would happen at end of life. And now we've got a big problem because at end of life, e-waste collection is very low, processing is really limited. We haven't got an adequate infrastructure for reprocessing what's already in the system, let alone what's going to come in. And then we've got a big challenge with criticality of raw materials, many of which are located in geopolitically sensitive areas, etc. So there's potential threat to supply, which could affect the whole data center industry. So the project was set up. I'm the academic lead. It was set up to really look at the whole data center ecosystem with particular emphasis on servers because they have the highest embodied environmental impact, but with a long-term goal to reduce waste and secure uninterrupted operation and service across the sector. But the circular economy is not just about recycling, which is a bit of a myth that's perpetrated. It's about resource efficiency, reducing over-engineering, etc., and in particular about extending product life through reuse. And we really, really need to do that because we don't have an adequate infrastructure for recycling at end of life. So one of the distinguishing factors of our project is that we collected primary source data by disassembling lots of servers and working out what they're made from, how they're made, etc. And then to collect information about PCB content, we sent boards to our French partners, TND, who pulverized the boards and then carried out a whole array of thermal and chemical processes and pyrolysis, etc., and then determined what and how much material was in each PCB. And we identified across the range there are normally about 12 critical raw materials, which is very worrying. So the other thing that distinguishes our project, there's a sort of global fixation on carbon, which actually it's important because climate change is important, but it can present very misleading results. I'll show you in a minute why, if you just focus on carbon. So we carry out comprehensive life cycle assessment, which includes many different criteria. And if you look at the chart on the right, a 2017 server, if you're just looking at carbon, it appears that operational impact accounts for 80% of impact over life, and only 20% is linked to embodied impact. If you carry out, using exactly the same server, but carry out a comprehensive LCA, you see that the split between embodied and operational impact is about 50-50. So at the moment, most LCAs that you see, published LCAs that just concentrate on carbon, are giving you very misleading results about the true impact of embodied materials, etc. So we carried out and developed the first comprehensive life cycle sustainability assessment of which includes environmental, social, and economic factors. And we also have a criticality indicator to raise awareness of this problem for non-experts. And all of this data was embedded and sort of underpinned the development of our compass, the CEDaCI, or Circular Data Center Compass, which was developed to allow the data center industry stakeholders to make informed decisions about procurement, as well as educating people about challenges of end of life, etc. So the tool includes 3 elements: compare, end of life, and eco-design evaluator. Because we've taken a whole systems approach to the challenge of data center sustainability and circularity, we need to look at all life cycle stages, and compare, which deals with refurbishment and product life extension, and end of life are very reactive. They are responding to what's going on at the moment, whereas the eco-design evaluator is a sort of proactive element in the tool, which is thinking about how to change the design of products to mitigate some of the challenges that we currently have. So compare, it enables you to build your own data center. There are presets. At the moment, we've got about 14, I think, servers in our model, but you can change a whole array of components, and so you can virtually upgrade servers and then compare the results at the end. You know, what do the changes in components actually mean in terms of environmental, economic, and social impact, etc. And you can either get a snapshot view or get a comprehensive PDF download document with more granular information. And then we have end of life. This is really important. There's, again, quite a lot of sort of myths and misinformation about recycling, etc., circulating. At the moment, in terms of e-waste, only 4 metals are reclaimed. That's aluminium, anything with iron in it, so steel, copper, and gold. Think about, I mentioned that there are up to 12 critical raw materials in data center equipment. Those are lost to, in the normal or current business as usual recycling process. So in our recycling models, you have the option to decide whether you're going to refurbish at end of first life and reuse your kit, to recycle using current industry method, or to recycle using the CEDaCI recommended method, which was developed by our French partners TND, and they reclaim quite a number of critical raw materials. So that's the future of recycling. At the moment, their project is pilot, and they are going to grow it and scale up and transform it into a large project. And then the final option is landfill, which we do not advocate, but we include it as a benchmark to show the benefits of recycling and refurbishment. And you see the results, again, as graphs, or you can have a downloaded and printed PDF with a lot more information. And then the final element in the tool, the eco-design evaluator. I don't think many people are aware of how critical design is in determining environmental impact, but up to 80% of a product's impact is determined during the design phase. So you really need to make the right decisions to ensure that your products are sustainable and that they will facilitate circularity. So the Eco-Design Evaluator, it's live, and you can, as you swap parameters or change parameters, etc. From the drop-down menu bits of the tool, you see the spider diagram change. The blue begins to change, and ideally it should be filled blue if your product is 100% circular. What we did to test the tool and also to develop a product that we believe embodies our sort of philosophy, if you like, we used the tool to design a circular server ourselves, and we measured it, the circularity potential against standard models, and you can see that they are bog standard, off-the-shelf HP, Dell models, etc. Their circularity score was 86 and 94 points, whereas our server came up as 212 points. And then here it is, beautiful CEDaCI prototype server. It has a modular platform, consistent component configuration. It's easy to disassemble. We reduced the overall mass by 33% by reducing wall thickness of the chassis, for example. We've rationalized the number of components and reduced the mass of plastics, replacing many with metals because you can't recycle plastic satisfactorily. It's much easier to recycle metals. So we're not just designing for the next generation of products, we're designing, you know, for future use. And the great thing for us that we're really proud of is that the design has been accepted and published on the OCP platform. And then we've done lots of outreach events to support industry, training lots of SMEs as well as larger companies. I've included the, sorry, that's my timer. I've included the CEDaCI link to the campus there, so please feel free to have a go. We've got a poster out, we've got a poster outside, although I should say that I wouldn't have been able to achieve this work on my own. We've had an absolutely brilliant team of academic, non-profits and industry partners throughout. And that's it. There's also a little video on the website to show you how to sort of walk you through the tool. Thank you very much.
Thank you, Deborah.